All right, we're going over the unit for Edpuzzle, and we have the ratio of two complementary angles. So complementary, remember, is angles that add up to 90 degrees, and the ratio is 14 to 1. Okay, so that means there was a greatest common factor taken out of that, so we need to figure out what the greatest common factor is. So 14 times some number plus 1 times that same number is going to equal 90. Now we're just solving a regular equation here. We have 14x and 1x combined to give us 15x. We're going to equal that to 90. 15 times 90, we're going to divide both sides by 15. So x is going to equal 90 divided by 15. So let's see, x is going to equal, and we'll pull out 90 divided by 15 is 6. So x is 6. Now you actually need to find the measure of each of those angles as well. So now we're going to go ahead and multiply. We're going to multiply 14 times 6. That's going to give us one of our angle measures. And we're going to multiply 14 1 times 6. And that's going to give us the measure of the other angle. So obviously one angle is going to be 6 degrees, and 14 times 6 is going to be 84 degrees. So what that means is my angles started out as a ratio of 84 to 6. So I can kind of look at this, 84 to 6. And when we simplify that, 84 to 6, that simplifies to this 14 to 1. And you can even check this on a calculator, and we'll kind of open this up. We might reference back to this. That's most scientific. We'll look for the scientific calculator. So if I were to simplify as a fraction, 84 and 6, it would simplify to 14, and 14 is the same thing as 14 to 1. Okay. All right, so on to the next question. Please find the solution to question 1b. Solve for x first. X equals and then the measure of each angle. Okay. On to the next question, we have a proportion here. Remember in a proportion, for example, like if I had 2/4 equaling 3/6, well, I know these are both equal to each other, right? They both equal 0.5, they both equal 1/2. Well, one property that's true is that when you multiply the numbers diagonal to each other, cross product, they are equal to each other. So here we had 4 times 3, and that would be 12. And here we have 6 times 2. That is also 12. Those cross products are equal. So that's the cross product property. Cross products are equal. So I'm going to do that here. Multiply 10 and 15. Multiply 17 with the 2x minus 2. I'll just put the variable. I like to put those on the left side. So we'll multiply 17 with a 2x minus 2. And then we're going to go ahead and set that equal to 15 multiplied with a 10. Okay, so now we just need to distribute. Okay, what is 17 multiplied to 2x minus 2? Well, 17 times 2, that's 34, so that'd be 34x. 17 times 2 again, that's just a regular 34 this time. And then 15 times 10, that's 150. From here, we're just trying to get our variable by itself. I would add 34 on both sides, and that's going to give me 34x is equal to 184. And our last step here, divide by the 34 on both sides. So x equals 184 divided by 34. So let's get our solution to that. 184 divided by 34 is 5.4. Let me check that really quick. Okay, just wanted to make sure that was right. And so we got 184 divided by 34. It is correct. It's 5.4, about 4.1. And since it's not an exact answer, I would make these a little approximates. There we go. Okay, go ahead and solve question 2b. What was your solution for R? All right, on to question 3. Determine the scale factor. Remember, scale factor equals new divided by original, because we're trying to figure out what is the number that we're multiplying the original figure by to get the new one. So first I like to look at, okay, what's the smallest side? Smallest side here is 6. The smallest side in the other figure is a 48. So I don't want to compare just based on where they are in the diagram. I'm comparing smallest to smallest, or middle to middle, or biggest to biggest. And we really only have to do those two sides. You can do the other ones as well, but they should all be the same because it's telling us to determine the scale factor, which assumes that they are similar. So scale factor is new over original, so it'd be 48 divided by 6. We'll go ahead and simplify that, 48 over 6 in a fraction form. Let's clear this. 48 and 6 simplifies to 8. So that would just be 8 over 1, or you can call it 8, or we would say just 8. So scale factor equals 8. And what that means is you're multiplying all of the original sides by 8 to make them the new ones. And you can kind of check just to make sure, like the biggest side, 12 times 8, yep, that's 96. That works out as well. And you can check the last side here, 8 times 8 is 64. So that works out also. Okay. All right, on to question 3b. Please find the scale factor Okay, now we're finding the scale factor given a graph. So it's still new over original. So for this, there's a couple methods or strategies. I like to just pick one of the points and write it out. Like for example, C is at 0, 2. That is the original. And my new is C prime. It has that little prime notation. So that's how I know it's new. That's this point right here. That is at 1, 2, 3, 4, 0, 4. That is the new. Okay, so now remember, scale factor is new over original. So we can't put the zeros over each other because that's not changing, but we could do 4, put the 4 over the 2 here to make it 4 over 2. And that's going to be 2. So what that means is that the new figure is twice as big as the original. Okay. Another strategy or method you could use is kind of counting the distance or spaces. Like, for example, the horizontal distance from B to D, that's 4 units. And then from B prime to D prime, that would be 1, 2, 3, 4, 5, 6, 7, 8. So you could also compare that as like 8 over 4, and that would give you a scale factor of 2 as well. So either by doing the coordinates or kind of counting a horizontal distance or a vertical distance. Okay, go ahead and find the scale factor for question 4b. Okay, now we're going to go ahead and dilate with a stretch factor of 3 around the origin. So that's from this point here. Now there's 2 ways to do this. One way is to count the units from that stretch point to the coordinate. So from this stretch point to L, I am traveling in a path 2 to the right and 2 up. Now, if I repeat that, 2 to the right and 2 up, that's essentially doubling the length. So I can go 2 to the right and 2 up. I'll have a point here. Now that's only twice as big though. I want to make it 3 times as big, so I need to repeat that one more time. 2 to the right and 2 up. And this will be my new coordinate. I'm going to call it L prime. Now for L prime, that's at 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. 6, 6. We're going to write down that coordinate, 6, 6. Now, the other strategy, since it is dilating from the origin, I know that the original L is at 2, 2, right here. If I multiply that by my scale factor 3, I'm getting 6, 6. So either strategy works, okay? To get from the origin to K, I'm going 2 to the left. If I go 2 more to the left, that's double the size. and 2 more to the left, that is now triple the size. That's k prime. That's now at negative 6 comma 0. And if you wrote down the original k coordinate, it was at negative 2, 0, which makes sense. If we multiply that by 3, that gives us negative 6, 0. And my new coordinate for m, to the right 1, down 2. Repeat that process, right 1, down 2. That gives me a figure twice as big. Repeat that, right 1, down 2. Now it's 3 times as big. This is my new coordinate for m prime. And if we wrote down the original m, it was at 1, negative 2. And so if I multiply that by 3, this would be 3 and negative 6, which is where we are here, 3, negative 6. And now all you need to do is go ahead and connect them. And we have our new shape that is triple the size of the original. Okay, so take a moment, go ahead and dilate or draw the image here. We're going to kind of do it coordinate by coordinate. Okay, so go ahead and tell me, what is the new coordinate for h prime? What is the new coordinate for I prime? The new coordinate for j prime? And the new coordinate for k prime. Okay. Now we're going to use our scale factor to help us find missing sides in a figure. So remember, scale factor is new over original. So if I'm going from original to new, I want to multiply by the scale factor. So I'm going to multiply by 5/9 because I need to know, okay, I'm taking the sides here, multiplying them by something to get the new sides here. Whoops, how do I undo that? There we go. There we go. Okay, so first one, we are going to take 18. We're going to multiply that by 5/9. Let me show you how to do this in a calculator. Clear all. Okay, so let's do 18, and then you can do like parentheses, and then you can get a little fraction here, and we're going to multiply it by 5/9. And you can do these in the scientific calculators that we have as well, and that's going to give us 10. And we're going to do 2 more fractions, I believe. Okay, so that's going to give us 10. So this side 18 is going to become this new side here 10. Okay, we multiply the original by the scale factor, we get the new. Let's do that for 27. Let's do 27 times 5/9 and see what we get for that. So 27 parentheses 5/9. Oops, let me go out of there. And that's going to give us 15. This side that was 27 is becoming this side here, which is now 15. Now, the opposite is true for the last one here. We have the new, and we're going backwards to the original, okay? So if you have new and you're going to original, you want to divide by your scale factor, whatever your scale factor is. So we're going to divide by 5/9. So we're going to take 20. We're going to divide it by 5/9. Now this looks kind of weird in a calculator. So open up a new line here. So I'm going to do 20. And then I would just use the divided by symbol. Here it's going to show a fraction within a fraction. I'm going to put 5/9 there. In your calculators, it would show like a little dash for the 5/9 are going. So 20 divided by 5/9. It's really like 20 times 9/5. It's multiplying by the reciprocal, right? So that becomes 36. And we want that to become a bigger number because we want the original. Because if we think about it, okay, 36, was the original. I need to be able to multiply that by 5/9 to get this new figure 20. Okay. All right, so let's look at question 6B. Go ahead and solve for first the length of FD. Okay. Find the length of DE. And find the length of CB. Okay, now we've got a similarity statement. So we're going to use that similarity statement to help us figure out the sides we're going to match up with each other to create a ratio. Okay, so we've got F or GF, that's the first letter, second letter, GF, that's going to be this side right here. First letter, second letter, that matches to side NM. NM, here's 65 here. So these two sides are what we call matching sides. You can circle them if you don't have a highlighter color. And we're going to put them over each other in a fraction. I'm going to do top triangle over bottom triangle just to remain consistent. So 65 over 117. Now I'm going to set this up with the other matching sides. So we have ML. Here's ML, second letter, third letter should match up with FE, and it does. Here we go. So these ones you can do a different color. You can maybe do like rectangles around them just so you can kind of differentiate them from the circle sides. So we're going to set that equal to, remember we did top triangle over bottom triangle, so we're going to do 70 over 13x plus 9. So from here, now we just have to set up a cross product. So we're multiplying these two values here, cross product, multiplying these two values here, cross product. So that's going to be 65 multiplied with 13x plus 9. And then we're going to multiply 70 with the 117 in either order. So we're going to need to make sure we distribute here. 65 times 13. Instead of going back and forth in the Desmos, I'm just going to type this in here. 65 times 13 is 845x. And then we've got 65 times 9, and that's going to be 585. And then we've got 70 times 117, 8,190. Now we're solving for x, so we need to get it by itself. We're going to subtract this 585 on both sides. And that's going to leave us with 845x is equal to 7,605. And then our last step is just to go ahead and divide by the 845 on both sides. And this is going to give us a value of x equaling 9. Okay. We can also match up all of the angles, and we can use our statement to do that. We can use the diagram. I like to use my statement to do that. So it's like first letter goes with first letter. Angle G would match up to angle N, first letter, F matches up to M, and E matches up to angle L. And then you got to do this side proportional statements as well. Okay, so we've got GF. GF is first and middle, so that matches up with NM. ML is the second and last, so that matches up with F and E. And then GE first and last matches up with NL first and last. Okay, let's go answer question 7B and go ahead and solve for x. Okay, go ahead and complete this section independently before moving on to the next question. All right, I'm going to zoom back in a little bit here. Okay, now we are trying to determine if these triangles are similar. Remember our triangle similarity shortcuts. Triangle similarity shortcuts. Remember, there are 3 ways to prove triangles are similar. They have 3 sets of sides that are proportional. They have 2 sets of sides with an angle in the middle between them that are equal, or 2 angles are congruent in the triangles. Okay. So first diagram here, we've got 3 sets of sides. So this is either going to be side, 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 similarity, or not similar. So we have to figure that out. We have to figure that out by dividing the sides by each other. So I'm going to do smallest side to smallest side. So smallest side is 40. And I'm going to do top triangle over bottom. Smallest side is 40 and smallest side is 56. So I'm going to put 40 over 56. Let's do the 2 middle sides. So 45 is the next biggest. 63 is the next biggest. So we're going to do 45 over 63. And then our 2 largest sides would be the 55 and 77. Okay, so we're going to divide this on our calculator, 40 and 56. Clear all. 40 over 56 rather. 40 over 56. There we go. There's our first one. And you can leave it as a fraction if you want as well. We've got 45 and 63. 45 and 63. You can put it back into fraction. You can leave them all in decimals too. That's fine. And I think we had, what was it, 55 and 77. So 55, 77. Now, if one of these was slightly off, it wouldn't be similar. But these are all simplified to 5/7. So this is 5 over 7. This is 5/7. And this is the work or the proof that you need to know, oh, yes, these are similar or not. So these are all equal. And so we would say side, 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 similarity. Okay. Go ahead now, look here and determine, are these sets of triangles similar? Okay, in the next diagram here, I've got two sets of sides marked. This side is blank. This side's blank. So we can't do side, side, side. But we can do side angle side, or it's not similar. So it's one of these two. Now, in order to figure that out, we need to know if the sides divide evenly with each other. So I've got my smallest side, 45, my smaller of the two sides, and this other triangle, 118. So let's do 118 over 45, or you could do vice versa. So I did top over bottom. I'll keep and remain consistent with that. And then we've got these two sides here, 182 and 70. And let's check that. So 118, 45. Clear all. 118 divided by 45. So in a fraction form, it's as simple as it gets, actually. And for the other one, we've got 182 and 70. 182 and 70. And that simplifies to 2.6. So if we actually compare them as decimals, they're very close. One's 2.6, 2 repeating, and one's 2.6, but they're not exactly the same. So we would say no, not the same, and then we have to circle not similar. And you should put something here like this simplifies to 118 over 45. This simplified, what did it simplify? 2.6, which in fraction form was 13 over 5. You can also put the decimal values for those as well. Okay. Now keep in mind the reason why I said it could be side angle side or not was, remember, there's this angle relationship. Bow tie angles, those are what we call vertical angles to each other. So those angles in the middle are equal. So if these would have simplified and equaled the same number, they would have been similar. Okay. So I'm going to have you try this question here on your own. Determine if these two triangles here are similar. Okay. Here we've got two triangles kind of nested into each other, that smaller triangle and then this larger overall triangle here. We have no numbers on the diagram, so we can't divide any sides. So we can't use side, side, side. We can't use side, angle, side. So this has to be angle, angle, or it has to be not similar. There's just not enough information to prove it. Okay. Now, something that they both have in common is this angle L. That's a reflexive. That's a proper term for it. I call it the same angle. Same angle. It is the same exact angle in this smaller triangle. Angle L is the same angle in this larger triangle as well. Okay. Now there's another pair of angles here that are actually equal. These lines, or arrows rather, indicate that the lines are parallel. Now remember, if we have parallel lines, so these two lines parallel, I can connect them with a transversal, and we can identify angles that are the same as each other. So I can kind of take this, oh yeah, we call those corresponding angles, these two angles right here. And we know that corresponding angles are congruent when we have parallel lines. So now on the diagram, actually I'm going to put 2 marks on it to differentiate it. 2 marks, there we go. I'm going to put 2 marks and I'm going to call that angle M, and this would be like angle PQL. So we've got 2 sets of angles. This angle L here was the same, this angle M and this angle PQL was the same. So I would say angle similarity proves that they're similar. Okay, now go ahead and decide, are these triangles here similar? All right, and here we've got all right, and our last pair of angles or triangles here, we've got an 81-degree angle B, is congruent to angle E. They're both 81 degrees, but remember, in order to be similar, so they're going to be similar because of their angles, or they're not going to be similar. We don't have any side information for these two triangles, so we can't do side, 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 and we can't do side, angle, side. So these are the two options. So now what we can do is we can take 180 degrees and we can subtract 81 and we can subtract 60. Let's go ahead and do that. So we've got 180 minus 81 minus 60 degrees, and we're left with a 39. So that would be here. Now, technically, you don't have to do the other angle. We can take 180 and we can subtract the 81 and the 40. We're left with 59. So this angle here would be 59. So we can see that they're similar to each other. They're close. The angles are close, but they're not identical. The angles need to be congruent. So not similar, and you could say only one congruent angle. And you would want to show the work that you did here in terms of like, okay, 180, we subtracted 81, we subtracted 60, we got 39, and that went here. And then we did 180, we subtracted 40, we subtracted 81, we got 59. So the angle 60 and 59, they're close to each other, not the same. Angle 39 and 40, they're close to each other, but not the same. Okay, they need to be identical. So go ahead in this set of triangles here, determine if they are similar or not. All right, and then the last type of question that we have here is a flow chart. Now, remember, in a flow chart, we have some evidence that we're gathering, and we're trying to then determine if the triangles are similar. So still like we were in the last sets of problems. So we're still using, that side, 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 angle, side, angle, or I'm sorry, angle, angle, similarity. So we're still using those three shortcuts, but now we're just giving or organizing our thought process in a more formal way. Okay, so we're still going to look at the triangles here. We've got a 38-degree angle in both of these triangles. All right, that's given information. Our two smallest sides would be our 15 is the smaller side, 21 is the smaller side. And then I would want to compare my two biggest sides, the 20 and the 28. Okay, so we're going to go ahead and compare these, divide them. I'm going to do the 15s with each other first. So 15 over 21. Let's simplify that. Let's see what that equals. We'll put that in a bubble. You can do a box or you can do a circle. Either way, my circle is kind of not that. I'll do more of a box here. Might look a little bit better. There we go. This is one piece of evidence. Then I also said, we said angle H was congruent to angle A. Those were marked on the diagram. Remember, they're both the 38 degrees. And then my two bigger sides, put that into a box. So we're just kind of organizing our thought process here. And then we've got the sides 20 and 28, and we're going to simplify that. Okay. So let's do 15 and 21. And actually, we can just kind of do this without our calculator. If we divide by, 3? 15 divided by 3 is 5. 21 divided by 3 is 7. So that's 5/7. And let's look here. We can divide by 4. 20 divided by 4 is 5. 28 divided by 4 is 7 as well. So 5/7. So those two ratios are the same. Yay. That means these triangles are similar. We had two sides. We had an angle. So now we can kind of prove that. And again, we would want to say, well, these are given information on the diagram. These angles were given. We didn't need to do any work to figure out these side lengths. We did have to do some work to just simplify and divide to make sure they were the same. So now we can put these three things together, and these three pieces of evidence prove that our triangles are similar. So I'd start out, let's do triangle DHK, and let's say that's similar to triangle. So if you start with D, that's going to match up to angle E right here. So I'm going to put 2 marks on angle D. I'm going to put 2 marks on angle E. Now, because the triangles are similar, this side and this side are kind of matching sides, so that's why angles E and D match up with each other as well. And we already know H and A match up. So I'm going to start with E, and then if H was next, that would mean A is next. And then I can't see my last letter here, but it's a B. Okay. And those triangles are similar. We're going to need a reason below here. It's side, angle, side, similarity. All right, so we're going to set up the proof for this last question. Create your 3 boxes or circles, whatever you prefer. We're going to kind of do this together a little bit. Okay. I'm going to have you do the 2 smallest side ratios with each other. Let's do that first one together. So our 2 smallest sides would be 55, and let's do smallest 84. And it doesn't matter, we'll go from left to right. And so we're just remaining consistent. So let's do 84 over 55. So I'd like for you to simplify that into a fraction form. So what is the fraction equivalent to 84 divided by 55? Okay. Now I'd like for you to find the 2 middle side lengths, divide them by each other, actually put a fraction here, middle and middle side lengths, and give the final solution here. And then I'd like for you to do the 2 biggest sides. What is the 2 biggest sides divided by each other? And simplify that, put it here. Okay, same reason goes below each of these. Go ahead and enter the reason now. Okay, I'm going to zoom out just a little bit, and let's create a triangle similarity statement now. Okay, so I'm going to do triangle RQS. And now you need to finish that statement. What is it similar to? And then provide the final reason. Why are those triangles similar out of the 3 triangle similarity shortcuts?